I'm going to record this session and I will send you a link to it. You're taking Algebra 2, correct?
Correct.
Okay. Probably you can verbalize most of your problems, but if you can't, take a picture. In other words, if they're giving you like a graph and they want you to answer questions about that graph, that's not something that can be verbalized very easily. And when you come across a problem like that, take a picture, send it to this email, and then I'll bring it up on my screen. You're seeing this right now, correct? My email address? Yeah. And that's the way it works. I have a drawing tablet here, and I'm writing on the tablet, and I can, draw triangles and A, B, and C.
So I know what I'm working on now is quadratics, and we just introduced square roots into them.
Okay, so that's fine. You don't have to send me a picture, but I usually I like to get this out of the way one time just so the student knows how that part works.
Okay.
But if you've got, especially since it's a short session tonight, if you want to verbalize all the problems, that's fine. Let's go. You can give me a problem and you'll see exactly what my tutoring style is.
Okay. Let me really quickly go to, she has all the papers online.
Okay. You can either go online yourself and get the problems and then verbalize them, or you can have me go to that online site and I'll bring the site up on.
Okay, then go to Ralston Valley High School. Just look up Ralston Valley High School on Google.
Okay, hold on.
You live in Colorado?
I do. I live in the King Carl area.
Okay.
Yeah. Ralston Valley High School?
Yep.
Okay. So is
that
it this top
link?
It's that first one?
Yep.
Okay. Yeah.
And then you're going to go
with a user ID, password, or anything? Or?
No, not for this.
Okay.
You just go to the academics tab, and then the first one is teacher websites under the academics tab.
Okay. Hold on. One thing is when the GoToMeeting is quite a memory hog of your computer. So it's tough to do most anything else when you're using GoToMeeting. It is asking me for a username and password.
218.
Hold on. Let me get my keyboard here. For the username, it's 218.
Yep. 67.
Okay.
16.
Okay.
And the password is N.
All lowercase?
All lowercase.
Okay, go ahead.
N9305937.
Mouthful. Let's sign in, see if we got in. Okay, I'll go ahead and save that in case we want to do this again like this.
Now, you're not going to be able to see her stuff on here. You're going to go back to the Ralston Valley page.
Okay.
That's just my portal where I can view a bunch of the RV page. Yeah. So under academics, RV teacher websites. Yep. RVHS teacher websites, the first one.
Okay.
And then you're going to want to, once it comes up, you're going to be able to select the category of what, your teacher's course is. So.
Well, just direct me here.
So department, it says, with the little down arrow.
Okay.
And select math.
Okay.
And then my teacher's last name is Hambleton with an H.
Okay.
So
and Algebra 2.
Right there in the middle, Algebra 2.
Okay.
And then on here, she's going to have all of her homeworks. We're in the second unit, so we're in quadratics, unit 2. So on the left side, it says Algebra 2, unit 1, unit 2.
Okay.
And Then this is basically all the homework that's happened in our unit.
Okay.
They have the answers in the worksheets.
Where are some problems? That's what we need.
Just any worksheet.
Okay. Tell me which one you want me to open.
Probably the most recent one, so scroll down a little bit.
You pick.
Okay. Yeah, let's do the October 8th one.
Okay. I just saw quadratics of using square roots. So what do I click on notes or?
To the right, there's the worksheet right by the purple text. Yep.
Okay.
And then that's the worksheet when it comes up.
Yeah, and then we can work on this. Okay. And I can, okay. Here, let me see if I can expand this just a little bit. Yeah, perfect. All right, how are you on these radicals?
Very confused.
Okay, let me help you out. When you are simplifying a radical, your goal is to find factors of that number where one of the factors is a perfect square number.
So a perfect square number being a number where it's a whole number that's the...
Here's your perfect square numbers.
Okay.
In other words, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, and you usually don't have to go much higher than that.
So for 120, I would just start doing the multiples of 120.
No. What you want to do is find factors of 120, one of the factors being one of those numbers.
Okay.
Okay. 25 is not a factor of that. 16 is not a factor of that. 9 is not a factor of that, but 4 is. So I can break this up into the square root of 4 times the square root of 30.
Oh, because 30 times 4 equals 100.
Exactly. I'm looking for two numbers that are factors of 120. And now, because that's a perfect square number, that becomes a 2.
Okay.
And that's actually your answer, because 30, let's talk about that separately here. If I had square root of 30, well, I can make that the square root of 5 times the square root of 6. I could also make it the square root of 3 times the square root of 10. I could make it the square root of 15 times the square root of 2. Notice that none of those are perfect square numbers. Which means that is fully simplified. If I cannot find a factor that is a perfect square number, then it's not simplifiable.
Now, for when you took the 4 and you turned it into a 2, what happened there?
Well, that's equal to 2. So
okay. So you just simplified it even further.
Root 30, it's 2 times root 30.
Yeah, perfect square.
Okay.
Okay, that makes sense.
Let's do some more.
Okay.
And that's always the goal. And it doesn't matter if it's got a coefficient in front of it, you're still trying to simplify square root of 60. Okay. So let's just work with square root of 60 for the moment.
Okay.
Can you find a factor of the square? Can you find a factor of 60 that is a perfect square? Yes. So it's what? Root 4 times root what?
4 times root 15.
Okay. Which becomes what?
Root 60.
No, that's going back the other way. In other words, what we want to do is we want to turn that into a whole number.
Oh, okay, which becomes 2.
2 root 15.
Yeah.
And now I still have this 5 that was in front. Well, that 5 just multiplies the 2. So
it's 10 root 15.
10 root 15, exactly. Now, you'll notice that root 15 is also root 5 times root 3, but that is not considered simplified. In other words, you're turning one term into 2 terms, and you don't really ever want to do that. You only want to turn it into 2 terms if you can pull whole numbers out of that.
Okay.
That's why you're always looking for one of these perfect square numbers. So
Okay.
if you can find a factor that's a perfect square number, you know you're going to pull a whole number out of
Uh-huh.
that. Okay? So
All
let
right.
me leave those, and let's do number 3, root 500.
All right. So I know 20 isn't 25.
It is.
Okay.
So let's try that. So
25
root 500
equals 25 times root 20. Yeah.
Okay. So now that's 5 root 20.
Uh-huh.
But root 20 can be simplified. Because notice that 20 is 4 times 5. So now I can write that as 5 times root 4 times root 5.
Uh-huh.
See how the 20 factored into 4 times 5?
Yep.
Okay, and that 4, square root of 4 becomes a 2. 2 times 5 is 10. Okay?
Oh, okay.
However, this took 1, 2, 3 steps. If I happen to notice that this is also a root 100 times root 5, and 100 is a perfect square, it immediately becomes 10 root 5 in one step.
Wow. Oh, okay.
So the moral of the lesson is that you don't have to find the largest perfect square factor, but it's more efficient. In other words, it'll be fewer steps if you do happen to find the largest. Now, frequently, it's tough to find the largest. So you can work it the way we did this one. You found one, 25. 4 would also have worked. 500 is also divisible by 4. There's a nice little rule to know about 4s. A number is divisible by 4 if its last 2 digits are divisible by 4. That number is divisible by 4 because 24 is divisible by 4.
Okay.
That number is divisible by 4 because 24 is divisible by 4. So if you're looking at numbers and you don't know whether you can pull a 4 out of that or not, just look at the last 2 digits. In other words, that is divisible by 4.
Okay.
Well, yeah.
So for like 120, since 20 is
divisible by 100 is. So that'd be 400 times 100. In other words, any multiple of 100 is divisible by 4.
Okay.
Okay. But it's also divisible by 100. So when you see hundreds, think 100 as the factor.
Okay.
And you'll do it in one step instead of 4. But you can always do these in multiple steps. Let me give you an example, a good example here. Square root of 48. How would you do that?
I would say, what perfect squares would go into that? You have 3. Oh, 16. Or wait,
Yes.
no.
No, that's the biggest one. And that's what you want. You want to do it this way. Because that immediately becomes 4 root 3. The way a lot of people would do it would be, well, 4 is a factor of that, so I'll make it root 4 times root 12, which is 2 root 12, but then root 12 can be simplified. That's 2 times root 4 times root 3. There's another 2, so now I have 2 times 2 root 3, so I get to the same answer, 4 root 3. It just takes me a few more steps. By recognizing that 16 was also a factor of 48, you did it in one step. Root 16 times 3, that's 4 root 3. Okay, so you can do it almost always with small factors. You don't have to find the absolute largest perfect square factor. It just makes the problem a few steps shorter if you happen to.
Mm-hmm.
Okay. Now let's look at something like number 4. Okay. Better yet, let's look at number 5 first, and then we'll go back and look at 4.
Okay.
I cannot simplify either one of these.
Yeah, because they're not perfect.
Well, there's no
They don't have
factor of
any in them.
6 that's a perfect square number, and there's no factor of 15 that's a perfect square number. However, I can multiply to turn it into root 90.
Which has...
In other words, root A times root B is the same as root A times B.
Okay.
That's all I did was multiply 6 times 15. Now, 90 does have a perfect square factor.
Isn't it 9?
Yeah, square root of 9 times square root of 10. So this thing actually does simplify to this, and yet neither one of them simplified.
Yeah.
So sometimes you have to do the multiplication and then just start the problem from there.
Okay.
Now, if we go up and look at 4, it's a similar problem, only with coefficients in front. So let's do 2 steps in one. Let's multiply the 3 times the 4.
12.
And then let's multiply the 6 times the 2. So it's 12 root 2 right off the get-go. And root 12 can be simplified. After a while, you start getting pretty good at knowing these numbers that can be simplified. The biggest criterion usually is it needs to be divisible by 4. Okay? Obviously, if it's divisible by 16, it's also divisible by 4. But 12 is certainly divisible by 4, so I can turn that into that. And that becomes a 2. So now I have 24 root 3. And there's your answer. And notice that I didn't have any root 3's to start with. That's okay.
Yeah.
Doesn't matter. That's they intend on you doing it this way here. Okay?
Okay.
All right. Let me erase all the ink on there. And how about you give number 6 a shot?
Is there a way I can... Do I have a little pencil tool or...
No, just do it verbally and I'll write. You talk and I'll write.
Okay, so this one's a little bit different because both of them don't have coefficients, but I'm assuming you just multiply the square roots together, right?
Okay, so tell me what line to write.
Okay, so 12, square root of 12 times square root of 6, which would be 72.
Okay, so I want to bring the 3 along.
Yeah, square root.
Oh, that's correct.
And then...
For beginners, for starters rather. And now let's look at square root of 72. What is that divisible by? What factors of 72 where one of them's a perfect square?
Isn't it 36?
Yeah. So that is
36
3 times square root of 36
times the square root of 2.
So what's the final answer?
Wait, what is... So 3... I know. Which one of those do I...
Which one can you turn into a whole number?
36?
Yeah, what's the square root of 36?
6.
Okay, so it's 3 times 6.
6, which is 18 square root of 2.
18 root 2. Not 30.
Okay.
18 root 2. And again, we end up with a root 2 that we didn't even start with. The last 3 problems, we end up with a radical, and it's not in any of the problems. But that's okay. Okay. So, okay. What else do we have here? Let me scroll down and bring some of these fractions up. Let's take a look at these. And this, same principle as multiplying. In other words, this is the square root of 25 divided by the square root of 3.
Okay.
Okay. So what's the square root of 25?
5.
So that's 5 over root 3. What's the problem with this answer?
One of them's a square root and one of them's a whole
No
number.
radicals are allowed in the denominator.
Yeah.
Which means you have to do a process called rationalizing the denominator.
Do you multiply the denominator by the numerator? Because I thought...
No, what you do is any fraction can be multiplied by the number 1.
Okay.
Without changing its value. That has a certain value. You're not allowed to change it. But you can always multiply it by the number 1. The number 1 I'm going to use is root 3 divided by root 3. That's the number 1, correct?
Yep.
What that gives me is 5 root 3 in the numerator. And now the denominator turns into a 3, a real number, not an irrational number.
So when you multiply...
Go ahead.
When you multiplied root 3 by root 3, and that turns into a 3?
Yeah, it always will. In other words, if I had something like 5 over root 7, and I wanted to rationalize it, I'm going to multiply it by root 7 over root 7.
Okay.
Because that will always turn the denominator into a real, not a real, a rational number. Square root of 7 is irrational. And math does not like irrational denominators. Don't quite know why, but there's a general rule in math that thou shalt not have an irrational denominator.
Okay.
So whenever you get one, you have to rationalize it. And the rationalization process is that, where you multiply the top and the bottom by whatever that radical is in the bottom.
Okay, and that only applies to if it's a radical in the denominator.
Yes.
Okay.
Yes. And there's going to be some others I notice here that are a little trickier. Let's do 8. You do 8 for me.
Okay, so this one's a little interesting because it's a fraction. Oh, it's the same thing. So it's 2.
Yep, exactly the same thing. So what is it?
So it would be the square root of, or 2 over the square root of 11, right?
It's the square root of 2.
Over the 11.
Square root of 11.
Oh, okay.
Because all you're doing is taking that and turning it into 2 radicals.
Oh, okay. Yeah, I forgot that you simplified the...
Yeah, it's the same principle as this. It's this principle. Okay? If I have 2 numbers multiplied, I can turn that into this. Or if I have 2 numbers divided, I can turn it into the square root of A divided by the square root of B.
Uh-huh.
Okay? These rules, very important. You're going to need both of them. Know that you can always do that.
Okay.
Okay? So, that again is square root of 2 over square root of 11. Now, I can't simplify either one of those.
Yeah.
However, I got to get rid of that irrational denominator. That's not
okay. So square root of 11 for both of them. Multiply both of them by the square root of 11.
What's that give you?
Square root of 22 over 111.
No, when you multiply the square root of a number times the square root of the same number, it's equal to that number always.
Okay.
Doesn't matter what it is. If it
always.
Was 7,
okay. Now I understand. Okay.
That's why we multiply the denominator by the square root of the same number. Because it's always guaranteed to turn it into a whole rational number. And that's your best answer. I can't simplify 22. 22 is not divisible by 4 or 9. Those are the only 2 I really need to check. So I can't simplify 22, and I have a rational number in the denominator, so that's it. That's my answer.
Okay.
Okay. Now, we don't have much time, and I see some equations down here. I do see one of these. Let's just talk about that for a moment. Okay, that's going to be this. Square root of 5 times square root of 2 all over square root of 9 times square root of 3.
Yeah, that's what I figured.
So I'm going to start breaking that up. And then that'll be square root of 10 over 3 square roots of 3. And now I got to rationalize that. So I'm going to do what? So I'm going to multiply top and bottom by just the square root of 3.
Okay.
I don't need to multiply it by the 3 square root of 3. Just multiplying it by square root of 3 will turn it real. Turns the top into square root of 30. Square root of 3 times square root of 3 is 3. There's already a 3 down there. There's your answer.
Okay.
Again, 30 cannot be simplified, square root of 30. If it could be, I would proceed to do it.
Okay.
There's certain radicals that aren't simplifiable. That's not simplifiable. Square root of...
Now, when you start off as square root of 5 times square root of 2 over square root of 9 times square root of 3, how comes you simplified the square root of 9 but nothing else?
Because that's a whole number. None of the others are whole numbers. In other words, that's irrational, that's irrational, that's irrational, that is rational.
Okay.
And a whole number, 3. So you always pull whole numbers out. That is what the simplification process is all about, really, is pulling whole numbers out, pulling that 5 out. Okay. Now, let's just cover one more of these. I got to cover this one because this is completely different. On this one, we have a similar problem. We have an irrational denominator. Well, I can't multiply by the square root of 3. That won't change it. But what I can multiply by is the conjugate of this denominator. The conjugate is always the same two terms with a different sign in between, like that.
Okay.
And since I'm multiplying the bottom by that, I got to multiply the top by that. Because remember, I can only multiply a fraction by the number 1. Well, there's my number 1 in parentheses.
Okay.
Okay. Now, what happens when you do this multiplication? The denominator turns into 25 minus 3. It just does. Because I'm multiplying by its conjugate, the radical goes away.
Yep.
End up with 25 minus 3, which is 22. In the top, I distribute the 4, so I get 20 plus 4 root 3. You with me? Now, I can divide top and bottom by 2.
Okay.
I'm looking at even numbers. So if I divide the top by 2, I get 10 plus 2 root 3. If I divide the bottom by 2, I get 11. And there's my final simplified answer that can't be simplified any further.
Okay.
Okay? So you have a couple of types here. You have this type where you just have a, number 9, you just have an irrational denominator. That's easy to handle. I'm going to multiply it by root 7 over root 7. What does that give me? It gives me 14 root 7 in the numerator.
7.
It gives me 7 in the denominator, but now I can simplify that. What's that simplify to?
You can simplify the...
What's 14 over 7?
14 over 7 is just 2.
Okay. So it becomes 2 root 7.
Yep.
Is the final answer on that one. And that happens a lot. And by that I mean that once you've rationalized it, a lot of times you can further simplify it because even now you have whole numbers that like 14 over 7.
Okay.
That simplify. So you're not always done after one step. You have to check what you have and make sure that you can't further simplify it.
All right.
Okay. Well, I'm sorry we didn't have quite enough time to get to these equations, although there's a lot to talk about. That's a full session, questions 13 through 16. would be probably a half-hour session just to get you so that you could make sure you could solve all of those.
Mm-hmm.
I mean, it's not something I can do in just a couple of minutes. But let's see, you had another session scheduled for tomorrow. Let's call this session a day. Let me bring up my calendar. And if you like, you can just schedule it looking at my calendar if you want.
So hey, David, this is Nate's dad.
Yeah,
So
David,
yeah,
hi.
so I can use that same link from earlier and schedule sessions.
Yeah.
Okay.
Incidentally, if you want to cancel and replace, the best way to do it is when you first scheduled it, you should have gotten an email as a confirmation.
Yeah.
In that email, there's a link that if you click it, it cancels it.
Oh, okay.
So you can cancel without calling me and then just reschedule on that same automatic scheduling page.
Wonderful.
Okay.
Well, now I think
I
we're
don't mind if
impressed
you
with
call.
your-
That's perfectly fine. It's no big deal. But if you wanted to do it all automatically, that's the way to do it.
Okay, great. So I think we definitely want to continue. So I'll schedule in the next day or two another session, and we'll move on from there. I really appreciate tonight. This is great.
Yeah. No. This. I think I can help Nathan a lot.
Wonderful.
On these.
Thank you so much. We look forward to talking to you some more.
You're welcome, Nathan. Good night. Have a good night.
Good night.
To sign off of GoToMeeting, just click on the X in the upper right, and that will disconnect. Well, one more disconnect. Good night.
Good night.